Good day, I'm Michelle Anterisi Tagalog and I am to discuss to you the manufacture process of alumina. Here are the contents of this presentation. The manufacture of alumina, extraction of aluminum alloy, manufacture of aluminum sulfate and alums, and manufacture of aluminum chloride. What is alumina? Alumina is the common name given to the aluminum oxide. Alumina is the most widely used oxide ceramic material. It's a white or nearly colorless crystalline substance, and it is mainly made from bauxite ore. Most of alumina are made yearly for the manufacture for metallic aluminum. Now, I will discuss the processes involved in manufacturing alumina. First is the Bayer process. It was invented by Austrian chemist Carl Joseph Bayer in 1887. It is a primary process by which alumina is extracted from bauxite ore. This ore is essentially hydrated alumina that is usually contaminated with clay, silica, and iron oxide. It contains 55% aluminum oxide and less than 7% silica. The said process yields 50% alumina. Here you can see a simple block flow diagram of Bayer process. Modern-day enhancements to the original 1892 Bayer process that there were two steps were added for the whole process. First is the press desilication, which is the removal of the silica, primarily precipitated out as insoluble as sodalite before the bauxite digestion. Since silica contamination is such a problem for alumina ceramics in all advanced ceramic applications. And next is the oxalate removal. For example, by calcium oxalate precipitation before the sodium hydroxide is evaporately concentrated for recycling. This is a flowchart of aluminum refining from Schreib's Chemical Process Industries 5th edition. The Bayer's process enables high-purity aluminum hydroxide to be separated from all the impurities that can be found in the bauxite. The main process outputs of this process is a pure aluminum hydroxide precipitate, and the waste sediment is called the red mud. And now, I will discuss step by step the whole flow for Bayer process. First is the crushing. The bauxite ore is first mechanically pulverized and milled to reduce the particle size and then screened to 100 mesh. In grinding, the crushed ore is mixed with the processed liquor containing caustic soda and processed in a grinding mill to produce a slurry containing 35 to 40% solids. The caustic soda is a sodium hydroxide solution that is used to dissolve the aluminum-bearing minerals in the bauxite to form a sodium aluminate supersaturated solution. In desilication, prior to digestion, the soluble silica is removed from the process solution or slurries by an initial desilication step in which the slurry is kept near atmospheric boiling for several hours to encourage the precipitation of solubilized silica to the silicate product. When bauxite is contacted with Bayer liquor, reactive silica dissolves and then precipitates as the sodium aluminum silicate known as the desilication product. The mixture is charged to digestion to achieve specific alumina supersaturation to ensure stability through these trains of flashing and clarification stages. Indigestion of the slurry by caustic soda at strengths exceeding 170 grams per liter in vessels under pressure at temperatures ranging from 145 to 265 depending on the type of bauxite being processed. The hot slurry containing the sodium aluminate solution passes through a series of flash tanks that reduce the pressure and recover heat that can be used in refining process. Next is the clarification stage. Bauxite residue settle at the bottom and is washed filtered prior to disposal. The slurry is pumped into the tank where the solution is clarified as an insoluble oxide impurities will not dissolve in the caustic and are separated from the pregnant liquor containing sodium aluminate by a process known as settling. In precipitation stage, the cooled filtered liquor is pumped through precipitation tank. Solid seed crystals of alumina hydrate from classifiers are being added to liquor through the top of tank. The precipitated crystalline aluminum dioxide, commonly referred as the hydrate or gibbsite, is precipitated from the cooled supersaturated liquor. During filtration, aluminum crystals are filtered to separate them from the caustic liquid. The precipitate is filtered from the liquor and washed. In calcination, the aluminum hydroxide is calcined by heating to 980 degrees Celsius in the rotary kiln. The alumina is cooled and shipped to the reduction plants, and the dilute caustic soda filtered from the aluminum hydroxide is concentrated for reuse. The red mud may be reworked for recovery of additional amounts of alumina. There are alternative processes for producing alumina. The first is the Mexican process called the UG process. The basic UG process commences with the hydroxylation of crushed alunite at temperature of 750 degrees. Alunite is a hydrosulfate of aluminum and potassium containing 10 to 15% alumina. After the dehydroxylation, followed by the reaction with ammonia gas in a boiling aqueous suspension. Filtration removes the alumina hydrate and potassium and alumina sulfates are recovered from the filtrate and sold as fertilizer. The alumina hydrate is treated with sulfur dioxide gas and resulting aluminum sulfate converted to alumina by heating. It is claimed to be capable of producing 99% pure alumina. The next alternative process is the French Peugeot-Eugene-Coleman process. Peugeot, French state-owned multinational holding company formed in December 1971 as Peugeot-Eugene-Coleman SA after the merger of Peugeot SA, an aluminum producer established in 1855, and in Society Eugene-Coleman, an aluminum maker and chemical company established in 1889. This process treats clays and shales with concentrated sulfuric acid. Hydrochloric acid is added during the crystallization step to form aluminum chloride, which crystallizes readily. Much raw material must be handled because the clays and shales have a lower alumina content than bauxite. The third process is the nitric acid process. It is one of the methods in the series of Bureau of Mines reports of investigations entitled Methods for Producing Alumina from Clay. This method is a treatment of clays with nitric acid. The last process is the Alcoa smelting process. Alcoa, the world's leading producer of alumina, made an alternative method for aluminum smelting. This process is based on chlorination of refined aluminum oxide resulting from the Bayer process. This method is a continuous electrolysis of aluminum chloride. The illustration shown is Alcoa's electrolytic cell from 1970s. And now we will discuss the extraction of aluminum alloy. In order to convert alumina to aluminum alloy, aluminum smelting using Hult-Héroult process is widely used in extraction of aluminum from alumina. Aluminum smelting is a very energy-intensive process and therefore electricity is a major input to the aluminum production process. It is an electrolytic reduction process known as smelting dissolves the alumina in a chloride bath inside carbon-lined cells or the reduction cells. Cryolite used as the electrolyte in the electrochemical production of aluminum from bauxite. This is aluminum compound which has much lower melting point than the aluminum oxide, and so using this reduces some of the costs in extracting aluminum. So these are the reactions happen in the Hult-Héroult process. So now we will discuss step by step the process happening inside the reduction cell. So first, the carbon anode acts as the positive electrode, and then the carbon lining serves as a negative electrode. The cryolite solution is mixed with alumina that is fed in the reduction cell. As electricity passes through the solution, an electrolytic reaction happens. Oxygen consumes carbon from the anode, forming carbon dioxide. The hot molten aluminum is accumulated at the bottom of the reduction cell. From the bottom of the reduction cell, the molten aluminum is tapped and transported to the cast house. In the illustration, the hot molten aluminum is being tapped by a crucible. Some end users require pure aluminum, but aluminum is usually alloyed with other elements such as silicon, magnesium, and copper to create special properties required for some applications and to make it stronger. Mixing takes place as the molten aluminum and other elements are mixed and heated in a furnace. The process is done using electromagnetic stirring technology. During casting, the molten aluminum with other elements is cast at a temperature of just over 700 degrees Celsius to form ingots, slabs, and billets and T-bars. So this is the summary of the aluminum smelting. You can watch the video links here to fully understand the whole process. And this is the overall process from mining of bauxite to aluminum alloy. The video link is attached in this file for you to watch and fully understand the whole process. Next, we will discuss the manufacture of aluminum sulfate and alums. What are aluminum sulfate and alums? Alums a double sulfate of aluminum or chromium, and a monovalent metal. It is a classical adjuvant most often used in vaccines in humans, includes a range of salts of aluminum precipitated under basic conditions. Alums usually are aluminum sulfate mixed with sodium or potassium hydroxide plus a variable amount of phosphate. Aluminum sulfate, on the other hand, is a type of alum that is not a double sulfate. Commonly used water treatment coagulant that when utilized with the associated alkalinity. It is produced by the reaction of sulfuric acid on bauxite. These are the sources of alums. First is the alunite ore. It is used from the 15th century until early in the present century as a source of potash alum and aluminum sulfate. Second is a bauxite ore that is most used ore for manufacturing of alums. Third is a cryolite ore. Fourth is a alum shale that is originally containing pyrite and after weathering containing aluminum sulfate formed by the action of sulfuric acid from the decomposition of the pyrite on the aluminous materials of the rock. And lastly, clays are also been found as a source of alums and aluminum sulfate. The flow chart shown is the manufacture of aluminum sulfate by Door process. In the table, these are the materials or utilities needed to produce 1 ton of 17% alum. To discuss further the process of manufacturing aluminum sulfate, first the bauxite ore is ground into a fine powder and next it is conveyed into storage bins. The mixture is charged into an open lead-lined steel reaction tanks where the reactants are thoroughly mixed and heated with the aid of agregators and live steam. Reactors are operated in series, and then barium sulfide is added in the form of black ash to reduce ferric sulfate to the ferrous state and to precipitate the iron in the last reactor. The mixture from the reactors is sent to a series of thickeners operated countercurrently, which remove undissolved matter and thoroughly wash the waste. The clarified aluminum sulfate solution is concentrated in an open steam coil heated evaporator. The concentrated liquor is poured into flat pans where it is cooled and completely solidified. And then the solid cake is broken and ground to size for shipping. To make alums, additional step is added to the aluminum sulfate process, mixing suitable sulfate salt with the diluted aluminum sulfate solution. The concentration of the mixed solution and then followed by cooling to produce alum crystals. And lastly, the manufacture of aluminum chloride. What is aluminum chloride? It is an anhydrous salt compound formed by the reaction of aluminum and chlorine solutions. In organic chemistry, aluminum chloride is the most frequently used Lewis acid in aliphatic Friedel-Crafts acylations and is one of the strongest. A catalyst in the alkylation of paraffins and aromatic hydrocarbons by olefins and in formation of complex ketones, aldehydes, and carboxylic acid derivatives. So this is the production process of anhydrous aluminum chloride. The chlorine is fed in below the surface of aluminum and the product sublimes and is collected by condensing. It will undergo metal chlorination due to aluminum metal and chlorine as a feed. These air-cooled condensers are thin-walled vertical steel cylinders with conical bottoms. Aluminum chloride crystals form on the condenser walls and are periodically removed, crushed, screened, and packaged in steel containers. Thank you for understanding, watching, and listening to my presentation. I hope you had a good day and stay safe. These are the references that I use in making this presentation.